Hello students, in this video I am going to talk about resistance and resistivity and how are they different from one another. Children, we know that the resistance is the hindrance or opposition offered by a conductor to the flow of charges. There are certain factors like the length, area of cross section and the nature of the material that affects the resistance offered by a conductor. Now we can imagine a piece of wire or a conductor to be very similar in structure to that of a cylinder. Yes. So we can say that the length of the wire will affect directly the resistance of a conductor. Similarly, the area of cross section or the thickness of the wire also affects the resistance of a conductor. Length of the wire has direct effect. That means longer the wire, more will be the resistance. Unlike the area of cross section, which means a thicker wire will offer less resistance as compared to a thinner wire. When I say nature of the material, it means that the resistance offered by a material like copper will be different from that of aluminium or silver. So we can conclude that the resistance of a conductor is directly proportional to its length, inversely proportional to its area of cross section. So R is proportional to L upon A. Now we will use one constant of proportionality called rho, which is a Greek letter, and this rho is known as resistivity, and it is expressed as rho is equal to R A upon L. Children, resistance will change with the dimension and nature of the material, but resistivity is a characteristic property of a material and it never changes. Its SI unit is ohm meter. This is a table that shows the resistivity of different conductors, alloys and insulators. If you see this table very carefully, then you will see that the metals and alloys have very low resistivity in the range of 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter, whereas the insulators have the resistivity in the range of 10 to the power 12 to 10 to the power 17 ohm meter. Alloys have higher resistivity than their constituting metals, so they are used in heating devices as they do not oxidize or burn at high temperature, whereas copper and aluminium with low resistivity are used for electrical transmission. Children, let us now solve some numericals or questions with the help of the formula for resistance and resistivity we have just derived, and will be more clear with the concept. This is a question which says calculate the current drawn by a bulb from a source of 220 volt if it has a resistance of 1200 ohm. We've already discussed in our earlier sessions that to solve such questions, you should first find out the given physical quantities. According to this question, we have the potential difference 220V, resistance 1200 ohm, and current is the quantity which we have to find out. We will use the formula of Ohm's law, B is equal to IR. Since we have to find out the quantity I, we will write this formula the other way. IR is equal to V, which gives I is equal to V upon R. Putting the values of V as 220 and of resistance as 1200, we get the value current is equal to 0.18 ampere. Now let us solve another question based on resistivity. The question says resistance of a metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. If the diameter of the wire is 0.3 millimeter, what will be the resistivity of the given wire? Let us first write down the physical quantities given to us. Diameter 0.3 mm is equal to 0.3 into 10 to the power minus 3 meter. To get the area of cross section, we need to calculate the area of a circle, which is pi r square. So we need to first find out the radius of the area of cross section, which is d by 2, which becomes 0.15 into 10 to the power minus 3 meter. We will use the formula of pi r square to get the area of cross section. Pi r square 3.14 into 0.15 into 10 to the power minus 3 the whole square. Length is 1 meter, resistance is 26 ohm, resistivity is the quantity which we have to find out. Now we have the formula R is equal to rho L upon A, or we can use the formula rho is equal to R A upon N. Putting the values of resistance as 26, area of cross section pi r square, and that of length as 1 meter, we get the value of rho, that is resistivity, as 1.84 into 10 to the power minus 6 meter.